feel to it.
Yeah, it's got an almost improvisational tone.
This semester on Stat 201, prepare yourself for YouTube, because we're all zoomed out. Cahoots and special guests, Tiny Brian, Puppet Shark, Evil Moobot,
I am Moobot.
Morty the Rabbit, and more. Super Statistics Bros.
Hey everyone, I'm wearing glasses today. It's my opening. Anyways, it's for a presentation. Gotta look smart, right? They'll be like, man, he's wearing glasses. He's so smart. So let's figure out some new stuff to learn right here. We are going to talk about, what are we going to talk about first? Well, let's get Moobot talking here with Review 3. So Review 3 has all of our cool stuff in here, everything we're trying to learn for the test. And Moobot should make it appear in a moment. There's Review 3. So what should we try to learn? If someone's in here and they ask a question, we'll review that material. Let's go look at the topics for the exam. Do we have anyone watching right now? I can look with Moobot. Zero? I'm not even watching, apparently. So we've got everything right here. Let's talk about tools and techniques. How about that? Let's talk. A lot of people overlook what are the tools and techniques. So the tools and techniques, good stuff right there. Tools and techniques. Let's take a look at tools and techniques. Okay. Let me timestamp this. So they keep adding new things to YouTube, and I'm like, what are they adding? Tools and techniques. We got 11:23 and Stat Tool 1, Exam 3, tools and techniques. So what are tools and techniques? Well, when it comes to tools and techniques, we'll just copy this over to here. The tools and techniques are what you learn in this class. So we want you to know how to use these things. So you have to think what all you've learned. And you can break it down into different parts right here. Let's break it into parts. You've got categorical data. You've got quantitative data. You've got bivariate categorical data. You've got bivariate quantitative data. You've got categorical / quantitative data. And what do we mean by this? Well, you have to understand Coda, good to see you there. We're just doing some review, but drop in the review what you want. So you have to understand what each of these mean. This is right here. We'll go off bold. Questions like, do you own a pet? Or what is your class level? What is your class level? These are all categorical. They put you into groups. That's just one categorical question. Next, we get into quantitative. How old are you? How much do you weigh? What's up, Logan? Good to see you there. We're talking about the tools and techniques part of the test. So we're talking about, like, you have to know how to both, let's say, how to graph / analyze data. So in this class, you learn how to graph and analyze data. So you have to know first the data type. I'd say that's the big question is, like, what kind of data are we dealing with? And I should put another one down here called lots of quantitative variables. Trying to publish something on that. Woo! So we have here bivariate categorical, which bivariate categorical is going to be like, do people off campus, are people off campus more likely to own pets? Are people off campus more or less likely to own pets than those who live on campus? That would be a bivariate categorical question. Bivariate quantitative would be something like, do people who weigh more, are they generally taller? We're not grammar here. We don't do grammar. categorical quantitative. That would be, do people who own pets spend more? Good to see you there, Vems. Good to see Sarah. Good to see Sarah right there. Do people who own pets typically or on average spend more money a month? On average, spend more money a month. And lots of quantitative variables. We'll talk about that one at the end here. But that can be like, are there relationships with age, height, weight, GPA, ... Okay, W, Sarah. Sarah's awesome right here. Thank you so much, Sarah. Always want to advertise your services for tutoring to help students out. So check it out if you're not on the Discord. Sarah's been a huge helper on the Discord and tutoring students. So Sarah, we throw some 50,000 points right here, Logan, right? So thank you very much. Really appreciate it. A lot of times questions get answered quicker than I can because I might be doing something or eating dinner or driving home, and then someone answers a question. I'm like, wow, I love that. So with this right here, we need to think of both a way to graph and analyze this. So we're going to have a box right here for each of these, graph and analyze. Can anyone help with the graph and analyze on categorical data? What is the graph for categorical data? So we're gonna write here, how do we graph this and how do we analyze it? So we need a graph and an analysis. So what do we mean by a graph? A chart, a figure, something to draw it out, some sort of graphic to draw a categorical variable out. So we have a graph, and then we have analysis, or analyze the data. So we can graph and analyze. Bar chart. Yes, I don't know why I said it that way. Bar chart, yes. And let's put it like that, organized. Okay, so bar chart is a great graphic for it. Anything else? Pie chart, Pareto, frequency table, and ring chart. It's literally this portion right up there. I think I got them all, but you should have a decent understanding. We say you can make a bar graph of your favorite pies. You can make a pie graph of your favorite bars. Marshall from How I Met Your Mother. But how do we analyze it? What tool or technique do we use to analyze just a categorical variable? Does anyone know what tool, like what analysis do we have for a categorical variable? And it's important to know that when we have categorical data, we'll just highlight it in blue right here. Do you own a pet is just one categorical question. So that's one categorical. How do we analyze it? How do we analyze it? Yes, it is with Z. Great job, Logan. One proportion z-test. Proportion z-test. Do we know the tables, or is just you should know a good bit of it. The more you know, the better. But like classic bar. Ring, not so much. Pareto, maybe. I almost did them in order of importance. It's a little bit by order of importance. Bars and pies are classic. Bars number one usually. You must know bar charts are a great way to graph categorical data. So that is very important. And the more you know, the better. It's what we've learned in the class. One proportion Z interval. So we have the one proportion Z interval and the one proportion Z test. Good questions. How about quantitative data? What is a way to graph quantitative data? Like, we'll just leave the how old are you so it doesn't look like we're doing bivariate. So you can do any question that leads to numbers. Remember that. So it's just a quantitative question right here, which is like, how old are you? So how old are you? Your age, but not age group, is quantitative. So what is a visualization for this? What is a visualization for quantitative? Histogram. Histogram right there. Histograms are classic. You should have a quick idea of what these look like. We can draw them beside. Bar charts and pie charts look like they say they are. Pareto is a bar chart put in order. Frequency table just has the counts of the observations in it. And a ring chart is a pie chart with the middle cut out. And then a histogram is going to look like this right here. We got a few others to put on here. And we can go in order of importance. Histogram's probably number one. There's probably a number two. I don't know if we put it number two on my graphic, but what would you say is number two for graphing something like this? What would you say is number two? Any guesses? Really good answers in the chat so far. So this is just the way to graph a quantitative variable. And there's multiple ways. Think about what we're talking about here is like if you do a painting, you could use oil-based paint, you could use chalk. I don't know if you're going to use chalk, but you can do it different ways. So when you graph data, you don't have to use a histogram to show your data. I'll mention a few others too that we don't talk about so much, but we're going to mention the big ones here, the big ones. And there's a cheat on the screen right now, and it's mostly in order. It's mostly in order by importance, I'd say. So what's another one? Box plot. A box plot, not multiple yet, not multiple. It's just a box plot. You can do them sideways or vertical. A box plot, and that shows the 5-number summary. The box plot shows that, which histogram is better at showing shape. Then probably stem and leaf, which a stem and leaf has the stem, and you put the numbers, and then you do the amounts. And so you can count the observations. And we don't usually go too big into detail on stem and leaves. And dot plot. A dot plot, which a lot of people think is a scatter plot. It's not. A dot plot looks like a histogram, but it has dots instead of the histogram, instead of the bins. So it has dots stacked on top. That's a dot plot. So how do we analyze one quantitative variable? Like if we want to make an interval to figure out the average age of UT students, what would be the analysis? To figure out the average age of UT students, what would be the analysis to figure out the average age of UT students, like to make an interval? So what would be dot plot? What would be the analysis? We're talking about quantitative. You know who we're talking about. You know the man, the myth, the legend who we're talking about here. So we're going to analyze a confidence interval for the average age of UT students. I said average. I didn't say his name or his quality. Mr. T. We're talking about one sample T interval. Usually, people might call this the T interval. It is called the T interval by default. So abbreviated, sometimes just called T interval. So if someone says, let's make a T interval, they probably mean a one sample T. There's the two sample T interval, but if they say T interval, they hopefully are referring to just one sample T, which means just analyzing the mean. If you do a two sample T, you're comparing two means for two groups. That'll be coming up here shortly. So we do have a one sample T test also. That's if you want to test a hypothetical value, like let's see if UT students are on average, because they are Lucy. See if students are on average a certain age old. You can then test that hypothetically to see if they're on average that age old, or you can make an interval to estimate the truth. How about bivariate categorical? What do we have for bivariate categorical? Help me out. What is a graphic for bivariate categorical? We have students living on and off campus, and do they own a pet? I'll clean this up while you figure out the graphic for bivariate categorical. What is the graphic for bivariate categorical? What is the graphic? Contingency table. And if you think about it, it's so we really only have two. There's other ones, stacked bar charts in Mosaic, more Mosaic. So Mosaic, we need a little more room to draw these. There's also stacked bar charts, which you're just adding bar charts on top of bar charts because you like bar charts so much. So you can do stacked bar charts where you have like the bars and then they're stacked on top of each other. Stacked bar charts. That one's not as important. Once again, I try to put these in importance order. Histogram, Mosaic plot shows you the frequency of each, but it also shows you the marginal distribution. So you can see how many are in each plot, but then you can also see conditional and marginal distributions. Conditional is when you go within the group, and marginal is when you go along the outside of it. So you can see conditional and marginal distributions with a Mosaic plot. And then a contingency table shows you a bivariate view of the amounts there are. So you would have the addition of all the values here, and you would just add them up and get something like that. And you'd have a contingency table, and that can be also turned into a Mosaic plot. So what is the technique that we just covered in class to analyze bivariate categorical data, like are students who live on or off campus more or less likely to own pets? The chi-squared test of independence, which you know when you see the Mosaic plot, it's chi-squared test. So chi-squared test of independence, which is chapter 19. Good job, Logan. Logan, I got to start working out again. That's my summer. Sure, I'll do it in the summer. I get a whole nother 6 months off. Anna, good to see you there. Gonna probably eat some pizza tonight. So with that, let's continue on right here. We now have bivariate quantitative. What is bivariate quantitative graphed like? Do people who weigh more, are they generally taller? People who weigh more, ignore the grammar, but when people weigh more, are they generally taller? So you might even be thinking of the plot, and then there's two techniques for this. Scatter plot. Logan, you're on fire, man. This is awesome. Scatter plot. Scatter plot, time plot, if probably won't be a time plot on the test. Like, won't mention it. If X is time ordered, like the price of milk over time, like weekly price of milk, since week is time and price of milk is quantitative, it would be called a time plot. So time plots are special case scatter plots. They'd look the same. It would just be that on the x-axis, it would have something like week down here. So it'd be week and then price. But you could do something like enjoyment of a product, like how much you like a product and the price of a product. And you could be like, the more I like a product, the more it generally costs. Or the price of milk has been steadily decreasing or increasing now. Who knows? And how do we analyze this? There's two techniques here that we have to look at a scatter plot and look at the bivariate quantitative relationship for the strength, direction, form, unusual features. We got regression and we got correlation. So regression is when we fit the line to there. Briley, good to see you there. Regression and correlation. They both consist of the line. Regression is more going to be interested in the intercept and the slope, where correlation is going to be more interested in the strength of it, which is going to be measured by R. Regression is also going to do R squared, which is correlation squared. So you can see the analysis of it has things like the intercept and the slope for regression, B0, B1, and R squared, the coefficient of determination known as the percent of variation Y explained with the variation X. And then the correlation is just the strength, direction, form, unusual features of a scatter plot, which is denoted by the value of R. Next, we get categorical quantitative, and this is, do people who own pets, are they more, do they spend more on months? Correlation is not causation, true there. Do people who own pets spend more on average each month? And let's copy our chart. Does anyone know the graphic we generally use for this? What is our numero uno graphic? Por favor. Me gusta mucho este. What is it? What is the very best graphic? Please. What would it be? What is the graphic going to be? Does anyone know? So you got to think, how would you display the amount people spend and if they own a pet? And there's hints on the screen if you want. I'm not blocking the answers. So this shows you all the combinations. We don't do logistics, so I have that crossed out. But you can see if the Y variable, there's just the Y. You've got your variables up there for quantitative categorical. We just did mosaic plots, continuous tables. There's also side-by-side pie charts. Once again, generally have them up. Yep, stacked histograms. You got it. Stacked histograms, great answers there, Briley. We've got stacked histograms. And with stacked histograms, you keep the scales the same. And we also got side-by-side, side-by-side box plots. And the reason is, and I might have to make this a little bit more like this is chapter 17. So if you're wondering, chapter 17, talking about right now. And let's go here. Stacked histograms look like you draw one axis, you draw another axis, you do your histograms, and you can see the differences. Side-by-side box plots are just box plots side-by-sided, so you can compare the 5-number summary. And it's possible that in these, they also add like a mean. Sometimes they add a little mean extra thing to it. We don't use stacked histograms that much. They're okay for comparing different shapes, but they get cumbersome if you have like 10 groups. Then you just want to do side-by-side box plots because it'd be like box plot, box plot, box plot. You can put 10 box plots next to each other pretty quickly. Like I'll grab a graphic of this. Side-by-side box plots. It's much easier to have a whole bunch of side-by-side box plots than it is to have like, here's a bunch of side-by-side box plots or stacked box plots. You see there, Abby. And you can see it's much easier to compare multiple side-by-side box plots versus if we were to go here and compare stacked histograms. It's usually, you could also side-by-side your histograms. Sometimes people literally stack the histograms on top of each other. It doesn't look as pretty. It's not as easy. This is called border histograms. And I'm not a big fan of stacked histograms. It's nice. So stacked histograms are okay. I would preferably do side-by-side box plots. But stacked histograms are a thing. They're fine. They're fine. Why are we hating on stacked histograms? And so what kind of analysis do we do with a categorical X and a quantitative Y to compare things? Now, remember, we have people who are on or off campus or own pets or don't own pets. So this is no, you don't own a pet, and yes, you do own a pet. What is the analysis? Anna, good to see you there. What is the analysis we do now to analyze these differences? That's a hint for chapter 17, because this is a categorical quantitative test. So what color did we do? We stopped shading these. Bivariate categorical should be this. So bivariate categorical means you have like on or off campus and do you own a pet. Bivariate quantitative, we did the other color. Do you weigh more? Are you generally taller? Height and weight. Not the chi-squared. Good guess. Not the chi-squared, though. The chi-squared is bivariate categorical. So bivariate categorical is chi-squared right there. Ah, yes. Great job. Yes, it is the 2-sample T. So the 2-sample T, I think we're doing this one, is categorical. So this makes the categories down here and then the quantitative Y. The 2-sample T test. 2-sample T. You could do interval, really. I wanted to go a space out, so we could say interval test. Either one, 2-sample T test, 2-sample T interval. One makes an interval of possible values, one tests values. But I did do another tricky one, which I think can appear in the tools and techniques. I don't want you to be tricked by it. I said lots of quantitative variables, and let's throw another 100,000 points here for the person who knows how we could do lots of quantitative variables. This is, I think it can appear as a question, so I'm trying to give you all those teaching to the test moments. I want you to try to figure out how we could graph or analyze tons of quantitative variables. Well, the hint is in they're all quantitative, like Q, 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 Q. So that just think along with what you know. I'll be shocked if anyone take a guess. I'll probably throw the points either way. And then we're going to change topics. But this has been Tools and Techniques for Stat 201. It's a lot of what you learned. This has been your semester. Any guesses? Well, if you reference what we've already talked about, remember when we did a bunch of quantitative variables? I might have changed the coloring. Well, that's quantitative. And then here's bivariate quantitative. Kind of. What we actually do is we make a scatter plot matrix. So scatter plot matrix or correlation matrix, which means the values over here are going to be correlation. So a correlation matrix, which is mentioned on like one slide, and then like never used again. A correlation matrix is all the pairwise correlations. So you can get every correlation between every variable. Does this ring a bell to anybody? It's just all the correlations between all the variables in a data set. So you just literally correlate everything. I know the graphic is probably really small, but it's every single correlation between every single variable. Margaret could see there. So you just correlate variable 1 with variable 2 and variable 3. And then this is the diagonal. You won't be analyzing this. It's just a bunch of correlations. Buddy the Elf spotted in the Vol shop. What's up, Buddy the Elf? Shout outs there. Definitely Buddy the Elf. So remember, correlation is for quantitative variables. So that's kind of the trick to this. If you have a bunch of quantitative variables, you just do a bunch of what's. So say it with me. Correlation is for quantitative variables. So if you have a bunch of quantitative variables, you do a bunch of what's. Like if you just do it between all of them. You look at this one versus this one versus you just do it all. This would be chapter. I wouldn't worry too much because this is good enough right here. You're not going to analyze a scatter plot matrix. You just have to know it exists. So correlation is between quantitative variables. And so if you have a bunch of quantitative variables, you do a bunch of what's. Finish my sentence. Correlation is between quantitative variables. So it's like two variables can be correlated. So if you have a bunch of quantitative variables, you could look at the what of all of them. You could look at the first with the second, the first with the... You could do a bunch of correlations. So that's all a correlation matrix is, or a scatter plot matrix, because you can make a bunch of scatter plots. Scatter plots are bivariate correlations or bivariate relationships between two quantitative variables. I wouldn't worry too much about reviewing all the old lectures because there's limited time. And the tools and techniques... Thank you, Vicky. Shouts to Vicky right there. The tools and techniques... You know what? Vicky's going to love this. The tools and techniques are general global ideas. The tools and techniques, Vicky knows about this right here. Go to the Vol shop, get your Smokey the dog. Check out Vol shop. Shout out to Vicky right there. It's in my office. It's over there on the side with my thank you cards from students and the nice things like nice thank you niceties. But now it's over here. Now it's next to the picture of Chelsea. Shout out to Vicky. So I need a Snoop Dogg figure. There can only be one Vicky. This is a good time right here for a little tiny break as we finish this topic right here, and we're gonna go to the next topic. Oh, there's only one Vicky. Vicky's like Highlander. Like there can only be one Vicky. Brian Mewbot bobbleheads. I would be happy if we made that, and I would do that for charity. I really want to do a charity like drive or something to help out either like students to do a scholarship or something, especially for students who are like, if we could make a Mewbot bobblehead for like $5 and sell it for 10 and try to sell like to all former students. Vicky has a Vicky got everything Snoop Dogg. Snoop Dogg needs to come to UT and meet his biggest fan. That would be awesome. Like there should be a change.org petition. Is that Darius? It is the Darius, I think, in the chat. Darius, good to see you there. Non-Mebucks aren't real. We're gonna switch topics here. We need like a change.org petition for Snoop Dogg to meet his biggest fan. Yeah, we need this. We need like a picture. If Vicky would be up for it. Could you imagine Snoop Dogg if he was like flying down to Knoxville or just chilling? He makes like a video. He's like, I'm going to meet my biggest fan. Snoop Dogg on UT campus. We got to make it happen. Charity collab with, if you want to, I'd do charity collab in a moment, Snoop Dogg. Okay. Thank you, Logan. Okay, what topic should we do next? You pick. We had our little bit of fun. We had our 2 minutes of fun. No more fun. What are we going to do next, everyone? I've got a little more time. I have class at 4. I got my presentation. You want to see who wants to see my presentation? Here's my presentation. Oh, it's over on this screen. Oh, man. Anything students get tripped up on. So here's my presentation. Slideshow. From current slide. We'll do a students get from current slide. There we go. Correcting the probability of observed statistical system findings based on richness of pairwise correlations. This is on YouTube. I can't show it, or else someone will be like taking my idea from John Tukey and gosh, I can't remember the other guy's name. Pearson, right? Carl Pearson. Okay. Let's do what students get tripped up on here. Let's do what students get tripped on. Ronald Fisher. Why am I calling him Pearson? He's Ronald Fisher. What do students get pipped on? What do students get tripped up on? Good to see you, Darius. Oh, the view. Yes. So let's do this. Okay. I really think students get tripped up on, I would say, notation problems. Any sort of like let's do conditions. They're nice, they're easy, they're to the point, and I think there's a few questions on that. Stat 201, exam 3, conditions for intervals and tests. Okay. So let's talk about the conditions for this test. Now, there's an easier way to memorize them. Let's go to our landscape mode for the piece of paper we have right here. So I think we can change the way, I think it's under reference actually, or no. How do I forget sometimes where the thing is at to change the way I want this paper to be laid out? Layout, of course it's under layout. So let's go right here to the orientation, go landscape. So now what we're gonna do is we're gonna talk about all the conditions. How many conditions are there for tests? There's sometimes what, or there's sometimes what. So this is you trying to remember from your knowledge before I tell you. There's sometimes 3, there's sometimes 4. Now, what's really great job right there in the chat. What's really great, I'll be adding them on once all grades are finalized. You'll see the grades change. So what's really great is that when we have 3 conditions, it's for the first few things we learn, and there's 4 conditions for the last 2 tests. So let's go ahead and go insert right here and make a table, and we're going to have the names of the conditions up top, and then we're going to have up to 4 conditions. We'll be doing some of those. We'll be doing some, and I'll be checking and giving some good advice. We'll do that here next, Margaret. You got it. So we first need to think about what we learned in order for this test. So we learned what to start. Cheat sheets right here. What was the first thing we learned a confidence interval for? Can you remember the first thing we learned a confidence interval for? Who knows? What was the first thing we learned? We're just remembering what we learned. It was a confidence interval for the what? A confidence interval for the what? This is chapter 13. Also kind of covered in chapter 15 a little bit when we do a test for this. Proportion, yes. So this would be proportion, test, or interval. So proportion, test, or interval is going here. They have basically the same conditions. There is a small caveat, but it won't be of great importance. You should know it. We'll cover it when we talk about it. What was the next thing we learned a confidence interval for, and we also tested? The next thing we learned a confidence interval for, and we also tested. So we learned a confidence interval of this, the mean. Great job. So we have the test or mean. Let's go t-test or t-interval. And we should also say right here very clearly one sample. So we did the one sample t-test or the one sample t-interval, meaning we're just testing one mean or making an interval for one mean. But now we switch it up in chapter 17. The numbers don't matter because they could change in the future, and I love using these videos in the future. What did we do next? We didn't just do one mean. We did what? Kind of, we can do the test with the greater than, the less than. We went to the two sample t-test or the two sample t-interval. And the two sample t-test is when you're comparing things like the average age of students on or off campus. You have to have two groups. You have on campus, off campus. Now, our last chapter that we just completed is what? What is our last chapter we just completed? Was the last chapter we just completed? The chi-square test of independence. And it's really great to remember its full name because it helps with the null and alternative hypothesis for it. So we did the chi-squared test of independence. But let's think, before we write down these conditions right here, what kind of data are we working with? Proportion data. Who can come up with a question for proportions in the chat? And this is a really good way to make sure you understand it. If you're dealing with proportions, when could we make like an interval? Like an interval to estimate what? So give me questions that would lead to proportion intervals or proportion tests. So then you have to know when to use it. There's a little tools and techniques here too. Brian believes 30% of students like statistics, exactly, which is categorical in nature. You're dealing with a categorical question right there. Everyone notice that? That is categorical in nature. How about when you are doing a one sample t-interval or one sample t-test? A one sample t-interval or a one sample t-test would be what? What would it be? Because you only have one sample. You have you talk to a group of students. That's what one sample means. You take one sample, not a sample of one, but you take like one group, a sample of 50 students. That's what one sample means. You don't have two samples, a sample of 50 here and 50 there. And you're right, it is quantitative, but what kind of question would it be from? You are very correct. I'll write quant as we do this. Because the more you can come up with your own questions for these and understand how it applies, the better you can apply the concepts. I believe students spend $10 on Arby's when they go there. Exactly. Just remember the examples you use in class. I love it right there. So I believe students spend on average $10 at Arby's, or you could make an interval to estimate the true average amount people spend, because you could take what do people spend on average, what's the standard deviation, let's make a t-interval for this to estimate the true mean, like on average, what do students spend? But now, what's the deal, as Jerry once said, Jerry Seinfeld, with the two sample t-test? So let's use Arby's. And let's use another variable. So spending at Arby's, what? What's the deal with the two sample t-test? What's the deal with the two sample t-test? So we have something like dollars spent right here. And then we have love of statistics right here. We're going to try this out. Ready? Look at that. Love of statistics. What's the deal with the two sample t-test? I haven't written everything for you yet. Well, you know the two sample t-test because when you hear Mr. T, you know Mr. T is mean, so you're dealing with quantitative stuff. But a lot of people make a mistake with the two sample t-test. And what they say it's quantitative, which it's not. You're testing the difference between two groups. So what should we add to this? The average amount students spend at Arby's based on what? The average amount students spend on Arby's based on what? So the average amount students spend on Arby's based on what? Like, is there a difference between the average amount students spend on Arby's? We could do grade level is good, but it might not be too sample then. Instant more. Well, so the two sample t-test would be: is there a difference between let's say men and women on how much they spend at Arby's, or is there a difference between students who live off campus when they go to Arby's and students who live on campus when they go to Arby's? You know, it compares two groups. That's the two of the two sample. The two is when we compare something like men and women over here, and we compare their averages. So there's a categorical variable involved right here. Is that a moment? You're like, oh, that's why it's called two samples. You have a sample of men, you have a sample of women, and you're going to compare their averages. So you can look at the box plots of it and compare on average. My wife loves Arby's. And who doesn't? They got the beef, right? They got the meat. Everyone loves Arby's. If you don't love Arby's, you can leave. And you can come back because you're welcome here. and bring us some Arby's. Okay. Wait, did you say it wasn't? It is quantitative categorical, correct. A lot of people think it's quantitative. Yes, Margaret, I like that. Let's throw 100,000 parts. Margaret said that you could just use 2 of the grade levels, and that is 100,000 points correct right there. Great job, Margaret. So you're very correct. You could just break it down to 2 grade levels, or you could group things together. So you could do a 2-sample t-test, and there is a technique called the ANOVA for more than 2 groups. So there is a way to do it. We don't cover it in this class, but there are other tools and techniques that go beyond what we do. The 2-sample t-test could be done like you can do it in ANOVA. So now we have the chi-squared test of independence. If you look at the way we've done this, we're only missing really 2 ways that this goes. What does the chi-squared test of independence deal with? The chi-squared test of independence, what kind of question could we have? Go with the Arby's idea again. Well, it'd have to be, do you eat at Arby's now? Hints. Or did you eat at Arby's this year? You could ask someone that, did you eat at Arby's this year? Because what is the chi-squared test of independence going to do? Here's a hint on the graphic. A hint on the graphic right here. We'll put the little graphic as a reference. We're drawing little tiny graphics. A histogram for the quantitative. People who eat at Arby's do... you would have to say pass-fail. Good, Abby, right there. Correct. So if you did, people who eat at Arby's are more likely to pass the test. So did you eat at Arby's yesterday? Yes versus no. And then we got pass versus fail. And let's just make it like this. I mean, what do you notice now? You have to look real hard at my graphic. But I mean, obviously you should do what before this test? Sunday night's going to be what night? We need to get sponsored. Hashtag sponsored. What's the deal right here? If you look at this little tiny graphic I drew, why can't I find the there we go. What do you notice about it? Do you see it? Everybody who ate at Arby's passed the test, as it should be. Go eat at Arby's. So with this is 2 categorical variables right here. It's categorical. Did you eat at Arby's? Did you pass the test? Does that make sense? We've switched from Taco Bell to Arby's. Now we get into the conditions. Now that we know what the tests are and how they're set up, categorical, have you eaten at Arby's? Yes or no. Quantitative, how much money did you spend at Arby's in an actual quantitative amount? Categorical quantitative, do men or women spend more money on average at Arby's? And categorical, did you pass the test? Yes, no. Did you eat at Arby's? Yes, no. Correct. The chi-squared test of independence is 2 categorical variables. So it has to be questions that can be answered with a category like, did you pass? Did you fail? Did you eat yes or no at Arby's? So it has to be a category of yes, no, pass, fail. It can't be a quantity. It has to be a category. So I hate qualitative. I like quantitative and categorical. I think it's easier to understand when we say categories. It's qualitative by some people's standard. It's synonymous words. But now we get into the conditions, and this is where I go, condition 1, random. I agree, so much better. Let's merge these cells. Because why am I doing this? For those who need to memorize, why are we doing this? Why are we doing this? What's the deal right here? What are we trying to say? It's no matter what we're doing first, it's going to be random, right? So random is the first condition, trying to space it out more. It's not just that one. Let's do this, right? And we'll copy this space. Might be a little random on how it's spaced, but there we go. So condition 1 is random. Yes. And then the next condition, condition 2, is 10%. So we're going to merge these cells, and then we're going to go 10% condition right here. And so 10% condition. What does the 10% condition mean? Let's talk about what these conditions mean. What does random and 10% condition mean? We'll call it the less than 10% condition. Less than 10%. I don't want to skip over any of these too quickly, lest someone's like, wait, I don't know what that means. Random means we took a random sample. You didn't just walk to Arby's and be like, hey, who here loves Arby's? You're like, let me talk to random students across UT. And then the less than 10% of the population says that you take less than 10%. Like if there's 30,000 students at UT or 35 now, you take less than 3,500. The reason the less than 10% exists is because of oversampling bias. where you don't properly do the statistics. There are corrections for these. So if you're wondering, I thought sampling more is better, gives you more power for chapter 16. That is true. Larger sample equals higher power. But then there are corrections that need to be done for very large samples to correct based on how you sampled. So that is something to consider. Now we do what? This is not a condition. When we used to do written tests, people wrote this as a condition. And I was like, it's not a condition. But we do this. What do we do here? We pause. We pause for a moment. We put those pause in the chat. The reason we pause is because now we have to think, which conditions are we talking about? Because if we're over here on categorical data, it's going to be success/failure. So success/failure. And there are slight differences for the, let me write it right here, for the test and for the interval. And we could do an example of this. I'll give you an example to solve yourself. Yeah, it's just practice. You get them down. For the test, it's, let me actually make this so it's off to the side. There we go. For the test, it is, really? Good. NP naught and NQ naught greater than or equal to 10. And for the interval, it's NP hat and Q hat greater than or equal to 10. So a test question could be the following. Let's write a test question for this. Really? Don't do that. Okay. It's going to do that every time I do it. I'm going to put the test question in the chat. Brian goes out and samples 500 UT students. He finds out that 2% of them are from, let's go 4%. From New York. Does he pass the success/failure condition? Okay, so Brian goes out and samples 500 UT students. He finds that 4% are from New York. Does he pass the success/failure condition? So right now, this isn't having you do a test. And I do pass it, right, Coda? So you want to mark your notation here. And the notation is going to be 500 is N, and this is P hat. And what is Q hat? So if that's P hat, what is Q hat? P hat is 0.04 rather. What is Q hat? What is Q hat? 0.96, exactly 96%. Great job. And then with this being P hat and Q hat, what do we then solve for? What did we get? N P hat equals N Q hat equals, what do we get from here? What do we solve for? Who is that? Hey, what? No way! Everyone! Christmas came early! Hey! What's up? I get my daily candy cane! Hey! We're gonna do a Buddy the Elf break. Great. Buddy the Elf, come on screen.
Okay, I'm on screen.
You're a disappearing head. Thank you so
Hello,
much.
everyone. What's up?
Oh, man.
Good luck with finals. Good luck with
buddy.
stats.
Thank you. I appreciate it. Woo! Oh, of course. Do you want a duck? You get this green duck. Let go. It's a coding duck. And you get to see my wife, so you can tell them it's an actual picture of my wife here. I tell them it's beside me, but they don't believe me. Buddy the goat.
I'm watching your stream right now.
You're watching it's stream inception.
That's how I knew you were doing this.
I was like, I think someone's here. I was like, and then I looked, I was like, I think I know who that is. I was like, that's awesome. All right, I am witness. That's awesome. Thank you so much. Good seeing you. Hey, I got a candy cane. Let's head back to the main screen. Man, I love teaching at UT. I love it. We got to put like Buddy the Elf. We're gonna put this in the video. 5203. Buddy the Elf. Okay. I hope everyone's having a great Christmas, great time. We really always have to have positivity and enjoy our times. Because if you're not having fun, if you're not enjoying what you're doing, why are you doing it? Good question, right? Okay, so NP hat and Q hat right here. is 20 and 80, because this is 500 times 0.04. Exactly. Positivity in these rough times. It is, yeah. I mean, there's so much like, we talk about rage bait all the time, but you have to focus in on the positive, and you need to bring the positive to others. And that's something that Buddy does really well. Or I don't know if he goes by Buddy, but our elf, the UTK elf, goes by. So, yeah, you have to bring the positivity through the nice bait. We all know about that here. We're pushing that. So we've done it. We have at least. Now, when we get to quantitative data, look up there at that histogram, because quantitative data needs to what? Quantitative data needs to be what? Quantitative data needs to be what? Quantitative data needs to be nearly normal. I was so confused. I was like, what's going on? Nearly normal. Nearly normal. Nearly normal. Let's just do a quick review of this. You ready? Because we're going to review each condition. When you talk about nearly normal, you're saying that it basically follows the normal curve. Sorry, Brian, right there. It basically follows the normal curve. And by basically following the normal curve, there's a lot of ways to do this. 1, look at the histogram. 2, does the normal probability plot follow a straight line? 3, does the central limit theorem large enough apply? And trying to think if there's anything else. Oh, the UTK elf. Oh my gosh. You should email me and I'll make you a mod. I think it's you. I'm going to go out on a limb. I'm going on a total limb. Standard mod. UTK elf, you're now also a mod for our channel. I told you, I said we should do something with Deadpool. You can get Deadpool on campus. But maybe next Christmas when I've laid off the Christmas cookies. Oh, I definitely had a lot of Christmas cookies already. You are always welcome. I always appreciate the positivity. We all need it. We all need it. I know you asked, but I can remember, how exactly do we check nearly normal? This is it right here. We also go more theoretically on these ideas. That's what, let's do it. You got it. We'll make it happen. And we get Vicky. So we've got, look at the histogram, and you see if it looks normal. Does the normal probability plot look straight? And also Shapiro-Wilk goodness of fit test. So we don't go too in-depth on this. We give more of a kind of idea of it. Does that make sense? We give the idea of how it works. So when you look at the histogram, what you're trying to do is you're just seeing if the histogram does what. When you look at the histogram, you're seeing what? Think about what you're looking for. Like, this would be good, and this would be bad. It's like, you can call it like naughty. It's Christmas. Nice. The shape, you're seeing if it's mostly unimodal symmetric. When you look at the normal probability plot, you want it to follow the straight line, so it should look like this, versus a bad normal probability plot is going to have some sort of weird bend to it. It's gonna go away from the line. The central limit theorem is based on the sample size. If you remember where we have like 1, 25, and 100, that if it's normal, you only need 1, which you really can't see. If it's skewed or very skewed. Does anyone remember this with the central limit theorem? That the larger your sample size is, the more normal the distribution of the means will be. The larger your sample size is, the more normal the distribution of the means. So such as you have a distribution right here, but let's say it's skewed. If you have a sample size of 2, then the distribution of means will be kind of more normal. But as n increases, gets larger, the distribution gets even more normal and tighter. So if it's normal, it doesn't matter. Rock knows. You could just have a normal distribution from any sample size. But the more heavily skewed it is, the wider n needs to be, which this is the central limit theorem here. The more heavily skewed it is, the wider n needs to be. Because now you see I have to make this even bigger and bigger. The more heavily skewed it is, the larger n needs to be. And this is the central limit theorem right here. So if you notice why I Google central limit theorem applet right there. So it's the central limit theorem. So that is like, if your data is normal, you only need a sample size of 1. If it's skewed, you need a sample size of 25. If it's very skewed, you need a sample size of 100. And so here's like one of those hints for the test. A sample size of 30 is not large enough. You can't just look at degrees of freedom. once, if you did the Canvas content, it said like degrees of freedom, which we sometimes steal from those questions. Degrees of freedom is not a way to check if you have a large enough sample size. Like you don't just look degrees of freedom greater than 10. Shapiro-Wilk goodness of fit test. If you pass on this, you have a high p-value. So you pass on this, you have a high p-value like point, it could be anything, 0.07. Sure, that's high enough. We'll go 0.24. And a low p-value means you have evidence of a bad fit, less than 0.05. And Hartman right there. We should have ELF icons in the chat. We'll add that here after this to MuBot. We'll take a short break. So that's the nearly normal. So when you have two quantitative variables, what's the condition? What are the conditions for two quantitative variables? So we have condition 1. What's the condition for two quantitative variables? What is the next condition? Two quantitative variables, what's the condition? Well, guess what? It's still nearly normal. But you don't do nearly normal for just one of the groups. You do it for both of them. So it's still just nearly normal because it's quantitative. So you go right here and you do the nearly normal for both groups. Who follows me on this? The third condition here is nearly normal for both groups because now you have two quantitative groups. So you have nearly normal for group, whatever it is, male, female. You do nearly normal for both of them. Then what is the fourth condition for the means when you're testing two independent means? What is the fourth condition for two means when you're testing independent means? So what is the fourth condition for testing two means when you're doing independent means? I kind of said it if you didn't get it. What's the fourth condition for testing two means when you're doing independent means? Independent means, exactly. Independent means. Yeah. So this means mean 1 is not impacted by mean 2. There's a separate test for this called the paired t-test when both values are kind of dependent on each other. Dependent means, paired means test. But independent means would be like I give students test A and I give students test B and I look which one has a higher average. Dependent means would be I give students a pre-test and then I give them a post-test and I see how they do after a lesson. So then you could compare student 1 to student 1 after, student 2 to student 2 after, and they would be paired. Does that make sense what pairing is? We don't go into big detail. Like we don't mention even the word on the test. But if you want to know why it's called independent means, it's like 50 students take A, 50 students take B. Whatever students make on A wouldn't matter for B. But if you have the same student take a pre-test and the same student take a post-test, it's now called paired because you'd actually be looking at the difference of the student before and after. So you still have two means, the mean before and the mean after, but whatever the student made on the test before would also be influenced what they're going to make after, like a lesson between. So now it matters. So that is the independent means. It means whatever group 1 is doesn't influence group 2. Like you could make two dishes. You could make a gluten-free dish and a gluten dish and have 50 people try the gluten dish and 50 people try the gluten-free. And then you could compare the average score of the dishes. And that'd be an independent means because whatever the people think over here is not going to influence the people who try this over here. They're independent of each other. They're going to think whatever they think of the dish if you put 50 random people in each group. But if you have people, like imagine you have people try a dish and then you educate them on the benefits of gluten and then you have them try a gluten-free dish. I don't know. I don't care if gluten-free. I'm not allergic. So if I was, I'd probably care. But if you had the same person do a before and after thing, that's usually the instance of pairing somebody because then you have to compare them. Okay, chi-squared test of independence. What is condition number 3 for chi-squared test of independence? What is condition 3 for chi-squared? Who knows? Condition 3 chi-squared. Who knows condition 3? Kind of. It can be that. There's no order to these. The notes even kind of put this first. I usually go count data right here. Count data means both variables are categorical. So all you have to do is look to see if it's categorical data. And it's similar to this. It's called expected cell counts greater than what? Expected cell counts greater than what? Expected cell counts greater than what? 5, exactly. And that's row total times column total over grand total. It is, oh no, don't you do it. Don't you do it, Briley. Or next person. Don't you do it. Don't you do it. MuBot. You behave, MuBot. You know he's gonna do it. Okay, so so with this, expected cell counts greater than 5, and we can do some examples of that here too. You should know how to get an expected cell count. So those are all the conditions. Once again, easy way to memorize them. Random, 10%, and then you have to pause and ask yourself what kind of test are you working with, because you're either doing success, failure, nearly normal, or onto expected cell count. Depends if you're doing chi-squared, t-test. T-tests are all nearly normal, and then the chi-squared and the proportions deal with having a certain amount. Also, you can think of the the expected cells, that if you have 10, you divide by 2, you get 5. I don't know. That never worked. I tried to tell students that. What should we do next? You name it, we'll do it. We probably have time for at least one more. I'm gonna try to head over a little bit early to my... Oh, and I need to announce tonight, if you're a BA... Is anyone here a BAS major? They're doing a really cool thing on our floor for BAS majors. I had it like announced to everybody, and then I was like, oh, it's BAS majors. BAS majors. But if you're a BAS major, we're doing a thing tonight on the floor here on the second floor. But be a BAS major. We should. Are you stats major, Briley? I think we should invite. There's not a lot of stats majors. Are you stats major, Briley? So I'm about to go say it, Charlotte. You're counting. It was a stats major. I'd get someone invited if it was a stats major. Yeah. Are you business analytics, Abby? Come tonight to the second floor, Stokely, and the big thing is like, I want to make sure. So here we go. Let me download this. I'm gonna marketing. What topic should we do next? Man, I'm getting all the students who want to come tonight for the free stuff, and yeah, here we go. For food. Abby, pick one. Pick a topic. We'll do one more topic. Let's do. What should be our next topic be? We'll just chill here for a second. Glasses die. Okay, I'm gonna send an announcement to my students. I'm too afraid to tell all my 201ers or something, because they'll be like, it'll be like a stampede. They'll be like, well, Brian announced it to his 201. I got free ducks for anybody. I got free Kahoot t-shirts till they run out. I should have given Buddy a Kahoot t-shirt. Oh, I should have done that. Should be like, and Buddy gets a Kahoot t-shirt. Swing by. Here. I want a duck? Yeah, swing. Oh, I didn't give you a duck? Yeah, I've got a bunch of ducks still. They're coding ducks. I usually at the start of the semester, I give them to like 320 and higher. Anything on chapter 19? Let's do chapter 19 next. Free food tonight and this week. Okay, insert. The problem is I'm doing a presentation, and I am so bummed that I am not going to get to be here for this split view. I don't care about split view. 1 second, we'll do that next. Aw, thank you. Tonight, this week. I want to see. I love it when my students come out to stuff. That is like. I want my students to win every award. I'm very competitive, and I'm competitive. I think whenever my students get a success, I don't think it's because of me. I think it's because they took advantage of an opportunity, but it makes me feel really good. It makes me feel really good. Commuters, hashtag commuters. It makes me feel really good when I hear like a student gets like a scholarship into grad school, an awesome job. I was looking at the board today, and we got people at Pilot, HCA, we got people starting their own companies, things like that. So I was like looking at it where I was like, I know that student. Like, you feel good knowing that they've had some success in their life. That's what you want to see. Okay. Getting a bunch of like Ted Russell Nissan. I don't need that. Okay. Wait, is everyone posting their thing now? Oh, it's like we're getting graded on stuff. I'm gonna go look at my grades, and then we'll do this last topic here. You like graded everything. Well, thank you so much. I'm looking at my grades, and we're gonna do chapter 19. How'd Brian do on his grades? Where's PhD? PhD philosophy. Grades, 5 grades. That was quick. Okay. I'm doing okay. I'm fine. I have to like flunk these last few. I don't even know what that means. Okay. Final paper. Oh my gosh. Our grades, right? They've been putting them out. They've been nice graders. They haven't been yeah, they've been releasing grades. They've been nice. So they're not grading too harshly. So I think you'll be good. Yeah, don't worry. I think no one's been disappointed in their grade. Yeah. Awesome, Margaret. That's good to hear. Yeah, they're working really hard and they have their finals. So shout outs to the graders. Let's throw 100,000 points. I want a 108. Tell me how it goes. I can look because I can see grades. Let's throw 100,000 points for the graders. Shout outs, graders. Let's do some chapter W graders. We really appreciate it. And they've been very responsive, very talkative, very good to work with. Sometimes I have graders who are harder to get a hold of. My graders this semester have been really amazing. Shout outs to my graders. Huge thank you. All 4 of them. I have 4 graders. And I'm very lucky to have 4 graders. So we are doing Stat 201, Exam 3, Chapter 19, chi-squared. Okay. To a certain extent, but not completely. Probably like I have half control. I can make suggestions and kind of pick from what exists, but not completely. But I'm very lucky, and I got another one of my graders who has done an excellent job. He's staying on and doing some stuff with me next semester, so I'm very excited about that. So shout outs, that grader. The SIs aren't graders, but they're awesome. Jake and gosh, I should know the other. Oh my gosh, how do I not know? So chapter 19. How about that? With chapter Maggie, thank you, Maggie. Thank you for thank you, Riley. Let's do points for Maggie right there. Sorry, I've known Jake for forever, and then Maggie's awesome too. 100,000 points, Maggie too. So thank you, SI, doing awesome work and helping out. Really great, and we love having students helping students. So with that, chapter 19. How do you know if you're looking at a practice test that you're doing chapter 19? How would you know you're doing chapter 19? Let's start chapter 19. And how do you know you're doing chapter 19? How do you know this? How would you know? Not too. It's like maybe 25% calculations. Don't quote me on that. A lot of multiple choice, a lot of true false looks like the Canvas content. So how do you know you're doing chapter 19? How would you know? What would clue you in? There's lots of clues to being chapter 19. What would clue you in this is chapter 19? How would you know? Well, we won't be using Excel sheets so much on the test, which we did that. Independence, the word independence, that's good. So it's the chi-squared test of independence, chi-squared test, squared test of independence. Ooh, now we got 2 categorical variables, which is what is required. This is the count data condition. So that's literally the count data condition. Oh, it is the last one. Yep. And then you have contingency tables, maybe. Contingency tables. You have a mosaic plot. Mosaic plot. I shouldn't do that to myself. And I'm trying to think if there's anything else, maybe. But release chapter 20. Rotowave in the chat. We got Rotowave bomb. Classic. We had Buddy the Elf come by today. Rotowave, check out this video later. We got a Buddy the Elf visit, and it's timestamped in the video. You can check out. You might have been here, Rotowave, for Buddy the Elf. I think you might have been. Awesome UT legend now, but Rotowave is another one of our UT legends. Just graduated recently. Congratulations. And so with this right here, mosaic plot, contingency table, these are all clues we're doing chapter 19. I love the null hypothesis. Easy, null, and alternative. Okay, so if we are doing, do you go to UTK? Imagine we go UTK in Florida and have you met Buddy the Elf? So we make a table right here of students who go to UTK in Florida. So we got UT in Florida. And then we have you met Buddy the Elf? Yes. Have you met Buddy the Elf? No. And then there's 100 students who go to UT and 100 students who go to Florida. And we will say 50 students have met Buddy the Elf and 150 have not. What is the null hypothesis? So this is school you go to. And this is met Buddy. What is the null hypothesis? Remember how it's the chi-squared test of independence? I know, right? That's kind of where we're going with this. What is the null hypothesis? What is the null hypothesis? What is the null hypothesis? Exactly. The null is that school you go to and meeting Buddy the Elf is independent. Like there's no relationship. Like you'd be just as likely to meet Buddy the Elf at Florida as you would at UT. That's what it means to say things are independent. I like to put it between like meeting Buddy the Elf is independent because they can just say it between the table. Like meeting Buddy the Elf is independent of the school you go to. But in the idea of independence, once again, is Brock knows it doesn't matter. Buddy, he might travel. Apparently, according to this data, he might, because I'm going to go here and write in the following that we have 2, 48, 52, and I think this would be 98, right? So how many people at UT have met Buddy the Elf? Look at the table. How many people at UT have met Buddy the Elf? So you have to read the table now. How many people at UT have met Buddy the Elf? And we can draw this out in our mosaic plot. We have a 50-50 UT Florida, so it'd be right down the middle. And we have 48% of UT, a little less than half, have met Buddy the Elf. And that's at UT for the yes, meet Buddy the Elf. Versus at Florida, only 2% have met Buddy the Elf. Does anyone follow how I drew this? This is Florida. So that there is 2% versus the UT right here, 48%. Does anyone, who feels like this makes sense? And it's 50-50 UT Florida because there's 100 students here and 100 students here. That's just the border of it. So, but 48% of UT has met Buddy the Elf. 2% of Florida has met Buddy the Elf. And these are all the observed, exactly. The good old mosaic plot. So, exactly. Rotowave, we got new memes this semester. We got all
Let him cook.
All the memes here.
Let him
all
cook
the memes
now.
at once
Let him cook.
happening.
I said, let him cook. It's morbid time.
Too much. So we have our mosaic plot, and the null and alternative is the null being going whatever school you go to is independent of if you meet Buddy the Elf, and the alternative would be what? I didn't say the alternative, but the alternative's just as easy. What's the alternative? What's the alternative? They are not independent. Exactly. And what does not independent mean? It means they're associated. Like the school you go to is associated with meeting Buddy the Elf. So now we have to go through and we have to solve to figure out if there is an association. So is it going to let me do it? Really? Sometimes I do not understand. I've used Microsoft Word for years. And then, oh, we did it. We did it. Oh, Sloan. Yeah, class president Sloan. Yep. That's, you see, I said every class. You can find Rotowaves. We're going to get serious here for a second, but class president Sloan. Oh, no. Did we not write president for the... I thought there was a quote on it, Rotowave, but he has his own level, but yeah, there's a Sloan class president. Like everyone voted him class president. We don't usually have a class president, but we did. So now let's figure out the expected values. So the next step here, after you write your null and alternative, is to get expected values. So expected values are found via row total times column total over grand total. So we are going to take the totals here of 100, 100, 50, and 150. And actually, we're going to reorient this just a little bit. We're going to put these hundreds on the bottom. It doesn't matter really where you put them, but I prefer it there. And this is UT, and this is Florida, and this is yes, and this is no. So how many UT students would we expect to have met Buddy the Elf? Who knows? And it's actually pretty easy to figure out. How many UT students would we expect to have met Buddy the Elf? Who can tell me in the chat? The formula is row total times column total over grand total is equal to expected cell. Half, you're right. So how many total? You are right, it is half. But how many? So the formula is row total times column total over grand total. So how many? There's the math. I'll highlight it for you. It's row total times column total over grand total. Oh, gotta choose next column. Oh wait, grand total's not there. Oof, someone catch me on these things. The grand total is 200. That's the grand total. I was like, that didn't look right. There's the grand total. So that's the grand total. Who's got it? I think it might have been my math. It was because of my error, 25. Yep. That was my fault. I circled the wrong numbers. But just think, when you check your math on this, do you see how it's half? Like, there's 100 students at UT and 50 students at Met Buddy the Elf. So you expect half of them to be at UT, right? Yeah, don't worry. It's good work, good practice. But you know what's really interesting? You can actually solve out every other value here. Like, you can move around the table, but because of the way this works, and there's only 1 degree of freedom, you can actually get every other expected value, which is going to be 75 not met, 25, 75. And it has to add up to the total. Nice job, Margaret. Great work. So you have to get them added up to the total right there, and these are all the expected values. So what do we do after we get all the expecteds? We now have to solve for the whats. After you get all the expecteds, you now have to solve for the cell chi-squareds, which the cell chi-squareds, a cell chi-squared is observed minus expected quantity squared over expected. There's the cell chi-squared. So we got to get the cell chi-squareds. Okay, what is this first one going to be right here? It's going to be observed of 48 minus, it might need to disappear. I'm about to block it. Let me zoom in. So does everyone see where I'm getting the 48? That is the observed up top. There was 48 UT students who have met Buddy the Elf. So 48 minus 25 squared over 25. That's it right there. And so that's going to be 23 squared over 25. It's going to be like 20.8. 20.8, I say. Oh, 20.8. I was close. 21.16. And this one right here. Who knows the formula for this one? Who knows this cell's formula? I'll give you a hint. It's still 21.16. The next ones are not going to be, though. The next ones, I'm going to do the next ones in my head, but you should be able to find them out before I do. Try and do the next ones in my head. So you hurry up and find them, because I should be able to do it in my head. 7.0533. 7.0533. I think that's it. Let's check these down here. These down here. Which the formula for that one is, we'll check my work. It's going to be observed of 52. So we're talking about, does everyone know we're talking about this formula? 52 minus 75 quantity squared over 75. And I believe it's 7.05333. Riley, does that make sense? David, does that make sense? That is the formula for this cell right there, because you take the 52 is the observed. I'll highlight. Let me remove this highlighting because we're doing a different problem and I only have so many color. We're doing the observed of 52, and that's what the observed is. We're doing the expected of 75, and that's basically it. And that solves out to the cell chi-squared, and the cell chi-squared is right here. So that solves out to the cell chi-squared. So this equals. Does that, I think people follow along. These are all the cell chi-squareds. We'll check our work. I think I've done it right. Let's find out. So we go here and do 52 minus 75 divided, well, square. Divide by 75. Wait, that's not right. 52 minus 75 quantity square divided by 75. There we go. 7.0533333. Math worked out nice. Okay. So what do we do now? Who knows the next step after you have all your cell chi-squareds? We found all the cell chi-squareds. What do we do next? Who knows what we do next? There's a full chi-squared test right here. What do we do next? We add them up. Yep, you take the sum, which that's sometimes, you take the sum of all these right here. And this is the value right there. It's 21.16. So it's going to be like, that's 14, that's 35, that's 35 and some change, 56 and some change, 56.3 or so. 21.16 plus 21.16 plus 7.053332. My gosh. 21.16 plus 21.16 plus 7.05333333 plus another one. Another one. Where's that at?
Wow.
And there it is, 56.42. Rips Arby's. Oh no. And so now what do we do with this? This is the chi-squared test statistic, the sum of all the cell chi-squareds. We have to find the degrees of freedom. And someone help me get the degrees of freedom here. Brian, this is a what by what graphic. Brian, that graphic is a what by what. So remember, it's like UT, Florida. Do you go to, did you meet Buddy? Yes or no? So Brian, this graphic is a what? It's a 2 by 2, turns into 1 by 1, so there's 1 degree of freedom, and this p-value is basically 0. It's way off the curve. When we draw this out visually, we're going to get a chi-squared with 1 degree of freedom, which looks like this right here, and we are so far off the curve, we're not even going to be able to see it. 52 is going to be so far off that the p-value, which is the area beyond, is basically equal to 0. So we're going to view that visually right here, that we have a chi-squared with 1 degree of freedom. And once again, that's because it was a 2 by 2, which you delete 1 row, delete 1 column to get the degrees of freedom. And then we drop in the chi-squared to find the p-value. So find p-value using chi-squared. And like I said, we're off the curve. So the curve is way back here. It kind of changed and didn't do it properly right there. Oh, that's not, we don't want that degrees of freedom. We want to find the p-value, and we go here and do this, and we are way off the curve. So we are all the way over here, and there's no area. So we could put in above that, and it's basically 0. It's going to be like 2e to the negative 23. Negative 14. Shouldn't get. I knew it was really small, but I thought it was even smaller. Well, I think that's got it. I think we're good to go. Let's see. I see like different things here. I Googled a random one from the homework. Oh, cool. Wait, why do I see 2 different chats? I see Briley's answer. Oh, there it is. I Googled a random one. Well, I think we've got a good video today. I might be able to come in and do more tomorrow because there's another meeting tomorrow. And so I'm planning on coming by. You're welcome, Briley. Let me save what's going on in the video. Huge thank you to Buddy the Elf. And thank you, everyone, for all your positivity. We'll do our fun. Let's do one of our fun outros here. Closings. Here we go. We got to do this in Haslam. Shout out to Haslam for always letting us do fun stuff. Coda, Briley, everyone, thank you so much. Abigail, thank you. Margaret, thank you. Bye from everyone. Bye. We've almost got these new intros ready. We're almost there.
This has been going for like 20 hours. This ends now.